All right, so today we're talking about physical properties. So, some examples of physical properties. Basically, a physical property is any characteristic of material that can be observed without changing the composition of the substances in the material. What this means is I'm not changing its chemical makeup. Um, I'm changing more or less maybe whether it is a solid, a liquid, or a gas. I'm changing its size. I'm changing something physical about it, but not its chemical makeup. So, some examples of these include viscosity, conductivity, malleability, hardness, melting point, boiling point, and density. So, those are all examples of physical properties that we're going to take a little closer look at. So the first one we're going to talk about is viscosity. This is a tendency of a liquid to keep from flowing. So things with higher viscosities are going to be thicker liquids that don't flow as easily. So things like honey, things like molasses, those are all going to be things that have high viscosities. Thin liquids such as water, vinegar, those are going to have lower viscosities that allow them to run rather quickly. Conductivity is a material's ability to allow heat to flow through it. So things with high conductivity are going to be good conductors of heat. So think about a skillet. Okay. The main part of the skillet is going to be made of metal, which is a good conductor or has high conductivity, allows heat to flow through it. But where you have to touch the skillet, the handle, you don't want all of that heat. So instead, this is usually coated in some kind of plastic or insulating material, which are not good conductors. They are poor conductors. Next, we're going to take a look at malleability. So malleability is the ability of a solid to be hammered without shattering. So when I look at this word, I see this first part here, mally. It's kind of like mallet or a hammer, right? Able to be hammered. That's what that means. Most metals, things like gold, actually gold is the best, are going to be malleable. Things like glass, things like ice cubes, if they're struck with a hammer, they're going to shatter. So they are not malleable. The next one we're going to look at is hardness. So when one material can scratch another, it's considered to be harder than the other material. This is one that gets used a lot in geology. There's actually a scale for hardness called Mohs hardness scale. I'll have some more information on that a little later. Some examples here, a kitchen knife, which is made out of steel, can scratch a copper sheet. This means that stainless steel is considered harder than copper. Diamond is the hardest known material to man, and it's actually used to increase the hardness of materials. So sometimes saw blades will have diamond in them, like small pieces of diamond in them, to make them stronger so that they can cut through materials that are harder than just stainless steel. Okay. Next, we'll look at melting and boiling points. They're just what they sound like. The temperature at which it melts, that is the substance's melting point. The temperature at which it starts to boil, which means it's going from liquid to gas, that is its boiling point. For water, if we're talking about the Celsius, or if we're using Celsius scale for temperature, melting point is going to be 100 degrees, or sorry, it's going to be 0 degrees Celsius. So at 0 degrees, water is kind of in that limbo where it can freeze or melt. Boiling point is going to be 100 degrees Celsius. So at that point, it can be a liquid or a gas. Okay. That's where it's just starting to turn over. Here, which of these substances are liquids at room temperature? I'm going to kind of walk you guys through this. So room temperature is 20 degrees Celsius. So if melting point is above 20 degrees Celsius, if melting point is below 20 degrees, here, let's pause. So room temperature is 20 degrees Celsius. What we're looking at is whether this 20 degrees Celsius falls between the melting point and boiling point for the substance. If it does, then that substance will be liquid at room temperature. So for example, gold, 1064.2 degrees Celsius is its melting point. and its boiling point is 2,856. 20 degrees does not fall between here. Gold is actually solid at room temperature. That's not surprising though. Table salt, same thing. Table salt, what's sitting on your table, is not liquid at room temperature. 20 degrees does not fall between here. Acetic acid, which is found in vinegar, 20 degrees does fall between here. So vinegar is liquid at room temperature. We're aware of that. Water, 0 to 100, we just talked about this one. 20 degrees does fall between here. Water is a liquid at room temperature. Octane, which is found in gasoline, which we know is a liquid if we've ever had to pump gas. 20 degrees does fall between 56.8 and 175.6, so it is a liquid. As we move up here, we get to ammonia and nitrogen and hydrogen. Their melting points are negative and their boiling points are also negative, which means 20 degrees is not going to fall between here. These are actually going to be gases at room temperature. So the only three that are liquid are going to be octane, water, and acetic acid. All right. Another physical property that we're going to be taking a closer look at, even more so later in this unit, is density. So density is the ratio of mass to volume, and it's used sometimes to find to test the purity of a substance. I have a few videos that I'm going to have you guys watch on each of these after this one, so make sure you watch those and answer the questions that follow.